Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with RF Elements. Today's host is Tassos Alexou, and he'll be presenting today. If anyone has any questions, please feel free to type them up in the question box, and at the end, I will ask Tassos these questions, and he'll answer them. Tassos, thank you very much. I appreciate your being with us today and sharing this new information with us. I am finished for now. Go ahead and take it on over.
Great, thank you. Good morning, good afternoon, everybody. My name is Tassos, and I'm with RF Elements. And today we'll be going over our Noise Rejection 101 webinar. It's a webinar about how to reject noise with our antenna products and a little bit better understanding of how the antenna products you may be currently using work. So at RF Elements, we deliver fast, sustainable wireless. And we do this by building antennas that reject noise, right? So our antennas have very good isolation and very good noise isolation. On top of that, we also have our twist port ecosystem. This is the connectorized adapters that allow you to take third-party radio systems and integrate them into our noise rejecting antennas. And these adapters give you nearly zero loss, right? So it's a very high efficiency connection mechanism, different than your traditional sectors. And when we combine this noise rejection with this extremely low loss connection apparatus, we give you this massive scalability. And this is scalability that's never been possible before. And it's something that's really necessary for today's outdoor wireless networks in keeping up or being able to deliver the demand and address the demand that most WISPs are seeing. So when we look at outdoor wireless networks, the key challenge there is really spectrum, right? So spectrum can be looked at two different ways, right? So the first part of spectrum is the available spectrum that you have. This is the kind of authorized frequency band and how much available spectrum you have in your area, right? So this changes from region to region, country to country. Some places have more, some places have less. But either way, it's a finite resource, right? It's a fixed amount of spectrum that you can legally operate in. The second part of that is in that that legal chunk of spectrum, the actual spectrum is being polluted with a lot of noise. So it's very difficult to find available channels. It's very difficult to co-locate your own APs, never mind co-locating with competing WISPs. So this is one of the challenges that we address with our antenna technology. If we look at the problem with the available spectrum, the problem is really antenna radiation patterns, right? So antenna side lobes are inherent to most legacy antenna solutions that are deployed today. So these legacy antenna solutions are these kind of traditional sectors that most people are used to. So the long rectangular patch array type sector antennas. These antennas have very large side lobes, and this is a really big problem. These legacy antenna technologies do not allow for exact beam angles, right, with appropriate radiation properties. So they vary greatly, not only the actual width of the beam width for the antenna that you're purchasing, but even the vertical beam versus, compared to the horizontal beam, there's a big mismatch, right? So it doesn't give you very precise radiation angles. So the RF noise that we're seeing is a result of this old technology being deployed in the field today, still after many, many years, right? And it's causing huge issues for yourself, for your WISP, as well as other WISPs, right? So RF noise is basically created by deploying poorly designed, outdated gear in very unsustainable ways. And we help address this issue. So again, the problem is an antenna with wrong beam angles and huge side lobes. You can't stress this enough. When you have an antenna system that's not very precise, that you're very unclear or the angle of the main beam and the side lobes, vary from antenna to antenna, it's very difficult to be able to plan and deploy your networks when you really don't know how wide or how narrow your antennas are. And RFElabcom's horn antenna technologies is extremely precise. So when you're using a 30, a 40, a 60, or 90 degree beam angle horn antenna, you're getting that angle, right? So it's extremely precise. Let's look at some different types of antennas. So this is a 3D model radiation pattern for an omnidirectional antenna. Basically, omnis are just one big side lobe. It's possibly the worst possible antenna you can use. If we look at the 360-degree coverage and the disbursements of clients within that coverage, basically any area where no clients exist, right, or any area of that 360 where you have competitive radios coming into that area is basically treating that part of antenna as a side lobe, right? You're transmitting in an area where you don't need to go, and you're also hearing in directions you don't want to hear from. So because of that, omnidirectional antennas are possibly the worst possible antenna because you have absolutely zero control over your signal. It goes everywhere and it hears everywhere. So again, we should probably try and stay away from omnidirectional antennas as much as possible. Here's a 3D heat map of a patch array sector antenna. This is your traditional sector. If we look at the dark area, these are the side lobes we're talking about. These are like the extra appendages that come out that are not part of that 60, 90, or 120 degree beam angle that you're purchasing. So if we look again at your customer disbursement within there, you can see in purple represents the area that goes way beyond the 60, 90, or 120 degree. The red area are the actual side lobes, and these side lobes usually go in the opposite direction, right? And they go opposite the direction that you want to transmit in. And at the same time, it's listening in the opposite direction of the area you're trying to service with this particular antenna. So patch array sectors are a very old technology and very ineffective for noise mitigation because they're typically too wide and typically have extremely large side lobes, which cause more issues than they fix. The same could be said for a parabolic dish antenna. So this is what a parabolic dish antenna looks like in 3D. Again, if we look at the dark shaded area, these are all the immense, really high intensity side lobes that exist. It's not just that nice little narrow, 7, 8, or 9 degree main beam that everybody likes to put in their spec sheets, right? So these areas are again just as bad for your point to points as the side lobes are in traditional sectors. Again, these side lobes reduce your throughput. These side lobes allow you to potentially misalign your antennas on short distance links where the parabolic dish antennas are too high gain. And of course, they're very capable of hearing noise from co-located backhauls or even potentially, out of angle. So again, a traditional parabolic has this really narrow beam, but if we look at the side lobes, we can see it really hears way beyond that, spec 6, 7, 8, 9 degree main beam or whatever it may be. Oh, sorry. Okay, so side lobes are basically a no-no, right? So again, if we look at a traditional sector and the disbursements of customers, you can see the very large area of noise, noise receptors and noise transmitters. When you start co-locating multiple sectors on a tower, you can start to see how these side lobes start to interact with the side lobes of your other APs, right? So it makes it extremely difficult to be able to co-locate multiple sectors on the same tower and mitigate noise because the side lobes are so intense, even though these radios are probably on different channels. You say, well, if it's on a different channel, then it shouldn't cause an issue. And that's quite frankly not true at all, because what ends up happening is the signal intensity from these side lobes to another radio on the same tower that's even on a different channel is still receiving that high intensity signal, and it makes it that much harder for your radio to be able to disseminate between its actual carrier frequency, the frequency it's on, and all the other sectors that are transmitting. So it makes it, again, it's a harder job for the radio to work when it has all this other high intensity signals from co-located APs, even though they're on separate channels. The same thing goes for backhauls, right? So if we look at a traditional beam pattern for a parabolic dish antenna, we can see when we fire up a second backhaul on that same tower, again, the side lobes are so intense that they are creating co-location issues and noise. And even for competing WISPs, right? So maybe you have a competitor on a tower, just a little bit down the road, on a building near you, whatever. Those side lobes are so large that they create problems and really make the ability to coordinate channels or find free channels that much more difficult, because again, they're not 7-degree beam width antennas. They're actually much wider than that, and it's because of the side lobes. As you increase the gain of an antenna, you increase the magnitude and the size of the side lobes as well. So for parabolic dish antennas, you're usually in the 30, 31, 28 dB range, right? That's about 10 to 12 dB stronger than your traditional sectors, which are about 19 or something like that. So as you stretch or as you focus that main beam to get that extremely high gain, you start to force the side lobes to be much larger and much more complicated. So the higher the gain of the antenna, the more complex and the larger the side lobes are. So the solution for all this is an antenna with a correct beam angle and no side lobes, right? So if we can get that exact 30-degree, 60-degree, or 90-degree sector with no side lobes, we start to eliminate a lot of the co-location issues we have, and we start to really eliminate the amount of noise that antenna can hear outside of its specified beam angle. Same thing goes for point-to-point antennas. Again, if you have that 7, 10, or whatever beam width, main beam only, and no side lobes, you have a much better performing system overall. So let's look at these point-to-points. Let's say we replaced one point-to-point antenna with a, let's say, ultra horn that has no side lobes, right? So you can start to see now there's no interaction, right? So already your tower starts to perform better because now it doesn't have to fight with your own backhaul on your tower. And therefore, again, it's a much better RF environment. Let's say you are able to convince your competitors to actually use the same antenna technology. Again, you can see if we replace it with an antenna, a point-to-point antenna that has 0 side lobes, now you have 0 side lobe interaction between your own APs and even your competitor APs. So you can start to see how this can help increase throughput, and more importantly, it increases your signal to noise ratio, your SNR, which is pretty much everything that's needed for today's very complicated radio systems. If we look at a point-to-point antenna in a linear scale, this is about a 10-mile link. You can see what the ratio is of the side lobes to the main lobes. So a traditional parabolic antenna has about a side lobe that's capable of reaching, almost a half a mile away. Most people doing micropops are using really high gain parabolic dishes to make these short links, and these side lobes are strong enough to be able to cause problems. If you look at the relationship on the right of the directional horn antenna, you can see that there's no side lobes. So again, when you start co-locating these backhauls, not only on your original tower, but also with competing WISPs right in your area, it really makes frequency coordination a lot easier. It totally improves GPS synchronization if you're using that as well. So there's a big difference between an antenna with no side lobes and the traditional sectors that most people are using today, which have very large effective side lobes. If we go back and we look at the point to multi-point, your sectors, right? So as we remove just one traditional sector and put up two 60-degree horn antennas here, you can see that the horn antennas are still not operating at their fullest potential because they still have the side lobes of the other two traditional sectors that are on that tower. So they still have to try and mitigate some of that noise. It's not until you replace all your traditional sectors with nothing but horn antennas where you truly start to see the full benefit of RFElabcom's horn antennas on your sites. It gives you the ability to scale your network up. It gives you some of the highest AP density per tower possible today. It's not possible with traditional sectors, not only from the wind load and the weight load, because horns are also smaller and lighter and have a smaller cross section, just overall the RF performance and then the physical performance on your tower makes a huge difference when you go to RFElabcom's horn antennas versus traditional sectors. Again, we can look at that linear scale of a traditional sector. If we look at that main wide beam, right, of about 5 miles, how far it goes out, when we zoom in and we look at the side lobes themselves, again, they're extremely large. They have a very effective range of over 1,600 feet, right? So, you know, trying to combat that when your APs are just a few feet away from each other, right? It's a big issue. Again, in this micropop world, everybody's going to micropops, you know, putting a bunch of sectors, you know, and having all these small cells every 1,000, 2,000, or 3,000 feet. If you build these micropops based off traditional sectors, you can see how the side lobe magnitude of traditional sectors are really a poor choice for this type of deployment, and horn antennas will give you no side lobes, so they allow you to not only co-locate high density of APs and antennas at your actual micropop, but all the other micropops in your service area will interfere less with each other as well. So big difference between the two. So there's more to noise rejection than just no side lobes. There's also gain, right? So if we look at this beam pattern here, this is the area of reception of a traditional sector. The blue line is the area of transmission, basically how far the signal goes. So you can see as we start to adjust our TX power down to service only our yellow clients, the gain of the antenna is fixed. So it's hearing the other radios at a high intensity, right? So if we use a lower gain sector, right, or a lower gain horn to cover clients that are close in and not use an antenna that has, you know, absurdly high gain for short distances, you can actually turn down the area of reception by using gain, and you can see that the signal that's received, right, by your AP for these other competitor stations out there now start to get turned down and possibly open you up to the ability to use other channels that weren't there before. So again, the right gain antenna is very important as well. It's not just about no side lobes. And again, we have seven different horn antennas available, everything from 30 degrees up to 90 degrees in 10-degree steps, right? So, you know, 30, 40, 50, 60, 70, 80, and 90. And all these different horn antennas have different gain, right? Everything from 18 dB gain in our 30 down to about 10.5 dB in our 90 degree, right? So if you're only going a mile or two, that's where your customers are, there's no need to use our 18 dB horn. You can use much lower gain. Or if you had to, because you need the AP density, you can use some down tilt to help reduce the gain at the horizon and try and tune it in some. So we definitely give you the flexibility, where with traditional sectors, you really don't have that flexibility. So I like to plug a new webinar we have coming out. It's our Antenna Mythbusters. It's a really deep dive into antenna technology, spec sheets, how to understand them, how many users are misled by what's in them, or just purely don't understand what they're looking at. So we have a new webinar that we're working on. Again, it's called Antenna Mythbusters. So you guys should keep an eye out for that. We'll be advertising it hopefully in the next couple of months. It'd be a great one for you to watch. So if we sum everything up here, there's basically 3 rules for noise rejection, right? The first one is use an antenna with no side lobes. So basically our horn antennas have no side lobes, so they're perfect for that. Use an antenna with the appropriate beam angle, right? So they only propagate and receive signals where it's needed. Again, horn antennas give you that as well. And then use antennas with moderate gain, right? Don't overkill your coverage area with high TX powers. Keep your EIRP limits within limits and only use as much antenna gain and TX power as you need for the area you actually have to cover. So when we follow these 3 basic rules of noise rejection, you'll have a much better running system than you've had in the past. We're coming to the end of the webinar here. So we have a pretty active forum. It's RFELabcom. I suggest if you haven't been there yet, check it out. There's a lot of great articles in there, a lot of great posts from people who have used our technology or people who have problems. It's a great place to post your problems and get actual users, right, actual WISPs to answer your questions to problems they may have had that are exactly like the problem that you're having. Also, our YouTube channel. This is by far the best resource for information. We have tons of videos of us traveling to visit WISPs and them explaining how they use our technology and how it's helped improve their systems. Also, like one-on-one interviews with customers, again, highlighting the main points of how they use our antenna technology. We also have old webinars and other sorts of useful information. So if you have questions, going to our YouTube channel, you might have a really good in-depth video that might answer your question pretty much as you need it. And then stay tuned, right? So we're very active on social media. Again, YouTube is one of my favorite resources there. Facebook, Google+, LinkedIn, Twitter, you name it, we're there. We're all over the social hemisphere. So if you're on any of these platforms and you have questions, feel free to tag us, RF Elements, and ask us questions. We're happy to help you. And just stay tuned for, again, new webinars that are coming out and even more exciting products that are coming down the pipe here, hopefully in the next quarter or 2. So with that, we're done. And I'm happy to take any questions, Julie, if you have any.
Thank you, Tassos, for that presentation. We enjoyed it very much. And yes, I do have some questions for you. Sure. Let's go ahead and get started with this first one here. Are the horns available in both 2.4 and 5 gigahertz?
No, they are not. Currently, all our horn antennas are in 5 gig only. We don't support 2.4. And just to get right to the point on 2.4, it's not really on our roadmap at all. So I'm not saying it won't happen, but the probability of it happening at this time is unlikely.
Thank you very much for that. Next question was about if you have a community forum, which you do. So thank you for that. Everyone always likes the community forum. Can anyone join, or is there a fee to join?
No, it's absolutely free. Again, so let me just put it out there. It's RFE for RF Elements, RFELabcom. Yeah, it's absolutely free. Again, even on Facebook, we have our RF Elements English group. We also have an RF Elements Espanol group for Latin America as well. So this is a great page within Facebook where there's a lot of interaction with customers in both English and in Spanish, where again you can communicate with other WISPs just like yourselves, ask questions. Of course, we're highly involved as well. So if it's a question directed to us, we usually respond within minutes. We're pretty on top of social media. And then again, one more time, our YouTube channel as well, right, which is RF Elements user. So.
Excellent. Thank you for that. We like that bilingual situation thing going on.
It helps. It helps.
Absolutely, absolutely. And we love YouTube as well. Next question. Is there a list of brands that your antennas support?
Absolutely. Everything is on our website. So if you go to RFElements.com and go under products, if you pick the product, it'll show you what is compatible. The horn antennas specifically are at the moment compatible with Microtech router boards, specifically like the 911, 411, that small square form factor. We have an adapter for that allows you to use our horn antennas with. For Ubiquiti, we have a huge line of SKUs for Ubiquiti, everything from the old Rocket M5, the Rocket 5 AC Lite, the Rocket 5 AC PTP and PTMP, as well as the most recent Prism and Prism Gen 2. So we have a ton of adapters that make those radios compatible with our twist port horns. And then for Cambium as well, right? So we have adapters for the EPMP 1000 and the EPMP 2000. So those two radio platforms are directly compatible with our twist port ecosystem. And finally, Mimosa. So we have an adapter for the C5C adapter, which will allow you to use that with any of our, again, horn antennas if you choose, or even our parabolic dish antennas. For all other radio platforms, where we don't have an adapter for, we have our carrier class line of horns. So if there's a radio, like maybe you want to use Cambium PMP 450 or something like this, or even Mimosa A5C, it's a very large AP radio that's not suitable for a twist port adapter. Our carrier class horn antennas are connectorized. They have two end connectors on there, so they can allow you to interface via an LMR cable to practically any radio on the market. So the difference is connectorized versus our twist port ecosystem, which has a very defined group. And again, if you go under that product on our website, we show all the compatibilities there.
Excellent. Thank you, Tassos. Next question here for you, and clarify if you've already answered this. But the next question here is, what other manufacturers does RF Elements make horns for?
Yeah. So again, RF Elements doesn't necessarily make horns for any manufacturer. We make horns. That's basically what we do. So again, if you go with our carrier class horn, then it's connectorized, and therefore it works for every antenna manufacturer. You just need an antenna pigtail to connect your radio connectors to our end connectors on our carrier class horns. So if you're using Microtech, Cambium, Mimosa, or Ubiquiti, we have a complete line of twist port adapters for a bunch of their radios. And again, everything's on our website.
Thank you for that. Next question. Are there any horns in the making that aren't already out at this time yet?
Oh, absolutely. You could rest assured that our engineering group never stops, right? So there's a lot of new products in the pipe. You just have to kind of bear with us here, and you'll be seeing them. You'll be seeing them soon. I mean, our most recent antenna was the Ultra Horn. For those of you who may not be familiar. And basically the Ultra Horn is the horn-based point-to-point antenna I showed earlier in the presentation, how you can replace noisy, large side lobe parabolic dish antennas with our horn point-to-point antennas that would give you no side lobes. And by the way, these things are working phenomenally in the field. So our Ultra Horn is the newest one. And again, we have more stuff in the pipe, hopefully, again, here in the near future, next couple of quarters, maybe you'll see a new product.
Excellent. Thank you, Tassos. Next question. You mentioned webinars. Is there anything in regards to informal training on the RF Elements line, such as mock tests or certifications?
I'm not sure. I mean, we don't offer any, not necessarily formal training. We do travel, right? So if you're a large WISP, or if you're a reseller or a distributor, that you sell these types of products, we're happy to host webinars for you and do training for your sales team or your engineering team. There's no fixed system within our company addressing that directly, right? But we do that sort of thing. So your best bet is to just email us, info@rfelements.com, and just open up a dialogue with us. I mean, we're happy to help. We work with the end users all the time and try and educate the industry, right? So you don't have to necessarily be a distributor for our antennas for us to teach you how our technology works. We'll do it one-on-one. We can even come out and visit as well. So just email us, info@rfelements.com, and let's talk about it.
Fantastic. Thank you. A couple more questions.
Excellent. I love
next one
questions.
here.
This is fantastic.
Okay. In regards to only 5 gigahertz, is 7, 9, or 11 on your roadmap?
Not 9. When you say 9, does that mean 900 megahertz? So you can answer that in the comments while I'm answering the rest of it, right? So at the moment, 5 gigahertz is again all we're doing. We are looking at some other frequencies. I'm not so sure. It's not an immediate roadmap for 11 gigahertz. That's the one. The 7 and 9, I'm not sure if you're talking about 7 gigahertz or 900 megahertz with the 9. So I need clarification for that. I will say that 7 gigahertz, I'm pretty sure it's not in the roadmap at the moment. And if your 9 was 900 megahertz, certainly not. That if anything, we'll go higher in frequency. Going lower is much more difficult because the horn antennas grow at a massive rate the lower you go in frequency. So 900 megahertz is pretty much an absolute no-no.
Thank you for that answer, Tassos. I appreciate that. Looks like we have one last question here.
Okay.
It looks like RF Elements offers a link calculator.
Yeah.
If we have further questions or need assistance, I know you mentioned about contacting you, but who would be the best person to contact regarding the inquiry here about the link calculator?
Yeah, absolutely. So I mean, I'll give you my email now. Please email me direct if you have any questions. It's Tassos, TASOS, @rfelements.com. If you happen to get it wrong, again, you could just email info@rfelements.com. I monitor that as well. So those are the 2 emails. As far as the link calculator, it's actually a very powerful tool, and we've been, streamlining it and learning from feedback from customers. It's actually extremely precise, so it works very well. If you go to our link calculator page and you scroll down there, there's 2 how-to-use videos. I suggest you watch those first, and they explain how to use the point-to-point part of the link calculator and the point-to-multipoint part of the link calculator. So you can do both sides of that. Again, if you're still unsure how to use it and you have questions, yeah, just reach out to us in any method possible, right? So my email direct, again, tassos@rfelements.com or info@rfelements.com, or just PM us on Facebook. However it is, we don't care. Reach out to us by any of these mechanisms, and be happy to work with anyone one-on-one and explain it in much more detail. Absolutely.
Excellent. Thank you so much for answering those questions, Tassos, and also thanks to everyone for attending today's webinar. If anyone has any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any products mentioned or shown here today, please visit us at www.microcom.us. And please remember, this presentation has been recorded and will be uploaded to our Microcom YouTube channel. Do it again. Thank you so much for your time and your presentation, Tassos, today. We appreciate it very, very much.
Yeah, thank you for having me. Thank you, everybody, for joining, and we'll see you next time.
You bet.
Bye.
Thank you.
Okay, bye.
Bye-bye.